All right, let's get right into it because what we're talking about today, this is not just another update. OpenAI's release of GPT-5.3-Codex, it really marks a huge shift in how we even think about AI. We're moving it from just being a tool to, well, a genuine collaborator. This is the dawn of the AI colleague.
And this quote right here, this is the headline. Our first model that was instrumental in creating itself. Just let that sink in for a second. This isn't some far-off sci-fi concept anymore. This is happening now. We are officially in an era where AI is starting to accelerate its own development. The OpenAI team said they were, and I quote, blown away by how much the model sped up its own creation. This is a massive milestone. It's the moment the whole AI feedback loop really starts to kick into high gear.
But the plot thickens. OpenAI dropped this bombshell just minutes after its biggest rival, Anthropic, announced their new model, Claude Opus 4.6. Now, that is not a coincidence. It's a crystal-clear sign of this incredibly intense neck-and-neck race to build the future of AI, and it is all happening right in front of us in real time.
So all of this just begs the question, right? How in the world does an AI actually build itself? What does that even mean? Well, let's break it down. See, this isn't just some clever marketing phrase. The OpenAI team literally put early versions of Codex to work on the final product. It was debugging its own code, managing its own deployment, and even dynamically scaling the GPU clusters it needed for its own release. It was an active, participating member in its own creation. A true feedback loop in action. It's kind of wild.
The reason it can do all of this comes down to a really core shift in its design. We're moving way beyond those simple AI assistants, and we're entering the era of the AI teammates.
And the key term you need to know here is agentic model. See, the older AI assistants, they just write a little snippet of code for you, and that was it. An agentic model, like this new Codex, is designed for the long haul. It can handle these complex, multi-step projects all by itself. It maintains context for hours, and it uses tools like the command line just like a human developer would. It's not just spitting out lines of code, it's a partner in the entire problem-solving process.
To see what this actually looks like, check out this example from Codecademy. You can build a whole professional-grade finance app just starting with a high-level idea. Then you just keep talking to it, adding complex features like local storage and CSV export. And then finally, you polish it up with things like a dark mode and goal tracking. The AI isn't just completing one simple command, it's collaborating with you over multiple steps to build a full, working application. Now that all sounds great, but talk is one thing. In the world of AI, the numbers on the benchmarks, while they tell a huge part of the story. So let's see how Codex actually stacks up in this great benchmark battle. Okay, first up, Terminal Bench 2.0. This isn't some abstract academic test. No, this measures how well an AI can handle the practical command line stuff a developer does every single day. Navigating file systems, managing projects. And right here, GPT 5.3 Codex takes a commanding lead over its rival, scoring a whopping 77.3%.
It's also just faster, a full 25% faster than the previous version. And that's not just a nice little bullet point. It fundamentally changes the experience. It means you can iterate faster, you get more responsive feedback, and it feels more like that real-time collaboration we've been talking about.
Next up is SW Bench Pro. Now, this benchmark is notoriously difficult because it pulls real bug reports and feature requests from popular open-source projects. And in this messy, multi-language, real-world environment, Codex sets a new state-of-the-art with 74.9% accuracy. It proves it can handle the complex, messy reality of modern software development.
But, numbers only tell part of the story. How does it actually feel to work with? Let's hear what developers who are using it every day have to say.
This quote from Dan Schipper at Every just perfectly captures the change. Codex is no longer that specialized tool you only pull out for the really, really hard problems, because it's so much better now, so much faster. It's becoming an everyday partner. It's a daily driver, right there in the workflow.
And here's a direct head-to-head comparison from Naveen Naidu. He gave a big, complex redesign task to both models. What happened? Codex executed it flawlessly, no build errors. Claude, its rival, it just stumbled and couldn't finish. And this highlights a key strength of Codex, pure reliability. When you know what you want, it gets it done.
So it really all comes down to this fundamental difference, almost like a difference in personality. You can think of it like this. Codex does exactly what you say. It thrives on detailed instructions. It's an executor. Claude, on the other hand, tries to do what you mean. It's a bit better with ambiguity. It tries to infer your intent. Knowing this helps you pick the right tool for the right job.
But the ambition here, it goes so far beyond just writing code. With these new capabilities, OpenAI is positioning Codex as a general-purpose agent for all kinds of computer-based work.
I mean, just look at the new spectrum of work it can handle. We're talking about writing product requirement documents, analyzing user research, creating slide decks, analyzing data and spreadsheets, even managing the entire software lifecycle. It's breaking out of the developer's terminal and landing on the desktop of pretty much every professional out there.
Which leaves us with this final, kind of provocative question. This new generation of AI, it isn't just a better tool, it's a different kind of tool. It's a collaborator, a partner, a teammate. And as we move forward, maybe the biggest question isn't just about what this tech can do, but how it's going to fundamentally change the way we work and create and solve problems together. So what happens when our tools truly become our teammates?